plot the curve in the frequency domain. Okay. All right. So at this value, if the omega and the wave number have this relationship, and we can have a frequency we call the cutoff frequency omega c, right? And the waveform is y equal to a e minus I omega ct. Okay, it's just like a omega frequency oscillation with the omega c. Yeah. So no any spatial variation, just a time variation about the diffraction. Okay, at a different time, I have a different y shape. Okay. Okay. So let's see the spectrum. Okay. Frequency spectrum. Right. Okay. So frequency spectrum is frequency versus wave number. Okay, and the curve will be we call the dispersion curve. Okay, right. So let's see. We have two equations, right? The first one case is gamma is equal to plus or minus omega square over c0 square minus k over t. This relationship. The second one is gamma. We have what? Let me see. We have a second case. We have okay. We have we have omega square over c0 square minus k over t. The square is equal to plus or minus I gamma bar. Right? We have this equation. Right. And the third one is cutoff frequency, omega c equal to c0 square over k over t. All right. Let's see the first one. First one, if I square of both sides, I have gamma square equal to omega square divided by c0 square minus k over t. Right? Right. And this you can reform it, become omega square over kc0 square over t minus gamma square over k over t equal to 1. All right. Maybe you can see, yeah. So omega square over C0 square minus gamma square equal to K over T, right? So divide by both sides, you can get this equation. So this is what? This equation is what? This is a hyperbolic equations, right? 双曲线, hyperbolic equation. So let's draw it. Note, if we have an equation minus x squared over a squared plus y squared over b squared equal to 1, it will have this is a, and this is minus a, and this is b, this is minus b. So we have equation of this one. And my hyperbolic equation is something like this. Okay, this is my hyperbolic equation. And this is x, and this is y. Right? Okay, so if you look at this equation, so for the omega square over, okay, let's see, minus gamma square over k over t square root square plus omega square over kc0 square over t square equal to 1. Yeah, this equation. Okay. Then what I have, I will have yeah. Let me draw here. Okay. This is my omega axis. And this is a real gamma solution. I mean, for this case, this real, right? Real gamma. So I will have a solution something like this on this plane. Okay, I have let's see. Okay. I will have an equation something like this. Yeah. No. Oh, no. Should be no, here. Anyway. And the dash is I'm not interested. Okay. So ours is a real axis here. This is 0. Okay. My wave number is positive, so I have this curve on this plane. All right. And certainly this is omega c at this point. Okay. Omega c is this value, right? Omega c is C0 K over square root T. So this omega c. All right. And for the second equation, yeah. Now talking about on this axis. So this I call the imaginary gamma, and it's equal to gamma bar. Okay, yeah. Then my equation is omega over C0 omega square minus C0 square minus K over T square root equal to plus or minus gamma bar I. This is my second equation. Right? So you square both sides, you have omega over C0 square minus K over T equal to positive and the gamma bar square I square. I square equal to what? I square how much? I square. This one. Good. Better I'm thought. Okay. So you rearrange this equation, you'll get gamma bar square over square root of K over T square plus omega square over square root of K C0 square over T square equal to 1. So this is an ellipse. Okay, ellipse. All right. So this ellipse is within this range, something like this. Omega c, and this ellipse like this. Okay, in this plane. All right, so we put close each other. So this is the imaginary part. This gamma bar with omega, this ellipse. Okay, and this is this value. This value is the square root of K over T. Okay, and this is a value. So this is yeah, and this minus square root of K over T, and this is omega c is the square root of C0 square K over T. Okay, and this omega c. All right. So this is the dispersion curve, and this is the standing curve. So if I put the 3D into a curve like this, this is a real gamma 0, and to this one is imaginary gamma is equal to gamma bar. All right. So this will be this is square root of K over T, square root of K over T, okay? And certainly there's minus for this axis. And this is this is a square root of k c0 square over t. Same thing. And this is a approximate asymptotic curve. Okay. So I put this one is like this. All right. And here is ellipse. Right? Do this curve. And this is omega c. I just bend this. All right? To this curve. All right. See? Yeah. And for any point, this is omega, and this is gamma. So this slope is c. So this is a phase velocity, and the tangent, the d omega d gamma will be called the group velocity something. Okay, we have group velocity and the phase velocity before, right? Yeah. And this slope, this one is c0. This c0. Okay, so the slope of this asymptotic line, approaching line, the slope is c0. Yeah. Okay, so this this omega and gamma curve, and we define the dispersion curve as a function for velocity. So let's see. Okay. Yeah. Dispersion curve, because we have the c0 equal to c square equal to c0 square 1 plus k k over t. K C 0 square. Oh, no. T gamma square. Okay, gamma square here. Okay. See my notes, equation 8. Okay. So this is equation. Yeah. All right. So let's see. If we plot this curve, horizontal is wave number gamma, and this is our propagation speed. So you plot the equation for For gamma is 0. Gamma 0, the wave speed is critical, right? It's critical. Critical solution, right? For gamma 0, the critical. So the C is equal to C0, right? For gamma equal to 0. 0. So it. So limit is what? You have to use the Edinburgh rule, the formula, right? Limit gamma to 0. C0 square plus C0 K over T gamma square, right?
应该要0分之0或无限分之无限才可以用。
不能用哈。我还有这个式子推错了。0分之0乘以。不可能哦，这个不会，这个 equation 是 for gamma 大于0，大于0 ，gamma 大于0，approach to 0应该可以啊，所以是什么？没有错了，0的时候它是无限大的。无限大，没错。0的时候是无限大，整个 term 是无限大，所以到伽马无限大的时候，它无限大，这个 term 就没有了，是 C0，所以没有错，就它 curve 是这样子。好 ，OK， 你看没有错哈，伽马等于0的时候不是它这个东西就会 push 到无限大，所以它是无限大。这样子，所以我会有一个so this is a dispersion curve. Dispersion curve for string. On an elastic foundation.